Okay, good morning everyone. In the previous lecture, we started with partial differentiation. So we have seen that all the rules of derivatives, those were there previously, are the same. Just one or two extra points are there that if you have two or more than two independent variables in your function, in that case, I can take the partial derivatives with respect to one of the variables. And when I'm taking partial derivative with respect to one variable, you keep the other variables as constant and you take the derivative. We have seen the notations, so I'll just discuss some of them. If there is a function of x and y, then partial derivative of z with respect to x is denoted by this dabba z by dabba x. So while I am differentiating with respect to x, we treat y as constant. When I'm differentiating z with respect to y, I'm treating x as constant. So in the same case, we can also take the higher order derivatives, second derivative of z with respect to x, second derivative of z with respect to y. This is also written as zxx or fxx. This is also written as zyy or fyy. Then we have seen the mixed partial derivatives. Mixed partial derivatives dabba to z by dabba x dabba y and dabba to z by dabba y dabba x. What is the meaning of this? This is nothing but, first of all, you differentiate z with respect to y, and then whatever resultant you get, then you take the partial derivative of the resultant with respect to x. In this, first of all, you take the partial derivative of z with respect to x, and of the resultant, you take the partial derivative of the resultant with respect to y. How it is denoted? Z xy. Look, the order is maintained. Xy, fxy. And this will be z yx and fyx. These two are called mixed partial derivatives. These are called mixed partial derivatives. These two are partial derivatives of first order. Partial derivatives of the first order. One more thing we have seen in the previous lecture, that mixed partial derivatives in general are not equal, but under some conditions they may be equal. Okay, so this is all, and some examples we have seen. So in today's lecture we will go ahead with solving some examples. So if,
Sir,
yes,
sir, Sharvil and one student is waiting outside.
beta Vinith, you have disturbed me this time. Please don't disturb me again. I have waited for 10 to 15 minutes, right? So they should join on time.
Okay, sir.
So you can put up a message, Vinith, join in 2 minutes, so that I will wait, and because once I go to that slide, I cannot accept the uh, request. So put the message over there. So if u is equal to x square tan inverse y by x minus y square tan inverse x by y, then find u of xy. First of all, u of xy is equal to partial derivative with respect to x of partial derivative of u with respect to y. So we need to find out the bracketed term first, and whatever resultant we get, we need to differentiate it with respect to x. So differentiating u with respect to y. So partial derivative of u with respect to y is equal to, so partial derivative with respect to y treating x as constant. Treating x as constant. So this will be x square as it is. Tan inverse y by x is 1 upon 1 plus y by x whole square by chain rule. Partial derivative with respect to y of y by x minus the second one, we will have to apply the product rule, y square as it is, 1 upon 1 plus x by y whole square, partial derivative with respect to y of x by y, minus, sorry, plus tan inverse x by y partial derivative with respect to y of y square. So this is x square in bracket partial derivative with respect to y. So this will be x square upon x square plus y square into 1 upon x. I'll open the bracket minus y square upon x square plus y square into Derivative of this with respect to y is minus x upon y square. Again, this minus derivative of this is 2y tan inverse x by y. And so this is x cube upon x square plus y square. This y square and this y square will get cancelled out. Minus minus will become plus x into y square upon x square plus y square. And the last one is minus 2y tan inverse x by y. So what we have got is partial derivative of u with respect to y. Now what we have to do is we have to differentiate this, differentiating with respect to x. So I can combine the first two terms, and what I can do is I can take this x common, and in bracket I will have x square plus y square. So that will get cancelled out in the denominator. So by u by y is equal to, let's combine the first two terms and take x common. So we'll have x square plus y square, and the denominator is x square plus y square minus 2y tan inverse x by y. So which is x minus 2y tan inverse x by y. Now differentiating with respect to x. Treating y as constant. So this is 1 minus 2y being constant. This will be 1 upon 1 plus x by y whole square. By chain rule, derivative of x by y with respect to x will become 1 upon y. So this can be simplified further, and what we get is the required answer. So which is u x y is equal to, so this will be y square. 1y will get cancelled out. 1 minus 2 y square upon x square plus y square. This is the final answer. Yeah, fine. Next example. If v is equal to c upon root t e to the power minus x square on 4 a square t, then show that partial derivative of v with respect to t is equal to a square second derivative of v with respect to x. Yes, how can we take the derivative? Anyone? Most convenient way?
Sir, we're first taking the log of v.
Oh, what you said? By taking
Log of v.
hmm, so we have seen this in where this given there is a variables in power and it is, I mean, to make this simpler equation what we take is taking log. The derivatives of this will become very easy, taking log. So log of v is equal to log of c upon root t e to the power minus x square upon 4 a square t. So this is equal to log c minus log of root t plus log of e to the power minus x square upon 4 a square t. So this becomes log c minus 1 by 2 log of t minus x square upon 4 a square t. Log e will become 1. Now I can differentiate it by whatever I want. So first of all, let's find out the left hand side differentiating with respect to t. So differentiating with respect to t. So log v will be 1 upon v, partial derivative of v with respect to t is equal to log t is 1 by t, so this is minus 1 upon 2t. This will be minus x square upon 4a square being constant will come outside. Derivative with respect to t of 1 by t. So partial derivative of v with respect to t is equal to v in bracket. This will be minus 1 upon t square. We'll make this plus. So x square upon 4 a square t square minus 1 upon 2t. The left hand side. On the other side, differentiating with respect to x partially. So 1 upon v, partial derivative of v with respect to x is equal to, first two terms are 0. In the third one, what we will have, minus 2x upon 4 a square t. Please check the calculations. V with respect to x is minus 2v into x upon 4 a square t. So what we need is second derivative with respect to x. So differentiating this once again, differentiating with respect to x partially. So what do we get? Da by 2v by da by x square. This will be equal to minus 2 upon 4 a square t. This will be constant partial derivative with respect to x of v into x. So I can see that v is the function of x as well as there is x. So I will have to apply the product rule here, minus 2 upon 4 a square t in bracket. Partial derivative of v with respect to x into x plus v. This is by product rule. Partial derivative of v with respect to x we have, so I will put this equation star in that. So what do we have? Minus 1 upon 2 a square t in bracket minus 2vx square upon 4 a square t plus v. So I can take v common now in this, and in bracket and this minus 1 upon 2a square t inside. So this will be 1 upon 2a square t minus, oh sorry, minus 1 upon 2a square t, and this will be plus x square upon 2a square t. And so I'll just rub this and write it down in a straight line so that things can be seen easily. So da by 2v by da by x square, what I've got is v in bracket x square upon 2a square t minus 1 upon 2a square t. So I can take a square common from the denominator, send it on the other side. So a square, second derivative of v with respect to x square is equal to v in bracket. So x square upon 2a square t, sorry, x square upon 2t minus 1 upon 2t. I made some mistake on that. This one is correct. Then second derivative will be upon 2a square t in bracket v minus vx square upon 2a square t. This is 4. So x square upon 4a square t. So this will be minus 1 upon 2t plus x square upon 4. So when we multiply by a square, so that will become minus 1 upon 2t plus x square upon 4a square t. So from the first and second equation, so this is the first one, and the second one from 1 and 2, 1 and 2, we have partial derivative of v with respect to t is equal to a square, second derivative of v with respect to x square. Fine. Go to the next example. If v is equal to x square minus y square f of xy, then show that vxx plus vyy is equal to x raised to 4 minus y raised to 4 f double dash of xy. Yes, can anyone give me the example of f of xy?
Sir,
Yes,
sir, can we take f of xy is equal to xy?
yes, that is one example. Any other?
Sir, x square plus y square.
X cube,
X square plus y square.
x square plus y square. Is it correct? Sarvesh, is it correct? Pratik,
Yes, sir.
is it correct? F of xy is equal to x square plus y square.
I don't think so. I'm not sure.
Okay, Tarun Gupta,
Yes, sir.
is it correct? F of xy is equal to x square plus y square.
Sir, I'm not sure, sir.
We're not sure. Vinith, Preeti.
Yes, sir.
Yes, Vinith. Is it correct? F of xy is equal to x square plus y square?
Um,
Don't know.
sir, I'm not sure about it.
Aryan, you have to understand the function. What
Excuse me,
is?
sir.
Yes,
Sir, may I tell?
yes.
So according to me, it is correct.
Okay.
Because it simplifies the V term.
Yes, Bhavika.
Yes, sir.
Yes, is it correct? F of xy is equal to x square plus y square?
Not sure, sir.
Not sure. Yogesh,
Yes, sir.
what do you think about this?
Sir, I think it is correct about.
Yes, correct. Okay, f of x is equal to x cube. What will be f of x into y then? Say f of z is equal to z cube. What will be f of x into y?
Cube y cube.
X cube y cube. So now can you understand the meaning of x into y? F of x y. So it is not written f of x comma y. So if it is x comma y, it will mean that it is this f is the function of it involves these two variables x into y. But what this means, this equation f of xy means that here f is the function of x into y. Are you getting my point? So when I say f of xy, it means that wherever a variable will occur, it will be like this x into y. So I can put this x into y as m. So it is simply f of m, where m is equal to x into y. So the correct function for this will be, say, sine of xy plus xy square upon 1 plus xy cube. So this f of x into y means that wherever a variable will occur, it will be like this x into y. It will never be in the form, I mean, separated x and y. The x and y will not be separated. So this expression means that I can put x into y as m and you will get a function of one variable. If there is any doubt, you can ask, or I will go ahead with this. This type of functions are going to appear from time to time in our syllabus now. So take a note of it. Okay, whenever there is x comma y, yes, it is our regular function. But if that comma is removed, then we have to be very much careful about what is there. I mean, wherever the variable will occur, it will be in the given form then. Fine. So what is our v? V is equal to x square minus y square f of xy. What we need to do, we need to find vxx and vyy. So differentiating partially with respect to x. So we'll have Vx is equal to x square minus y square as it is, partial derivative with respect to x of f of xy plus f of xy partial derivative with respect to x of x square minus y square. So this will be x square minus y square as it is. Yes, anyone, what will be the derivative of f of xy?
Y into f dash xy.
So this will be f dash of x into y by chain rule, derivative of xy with respect to x, that will be y, plus derivative of x square minus y square is 2x f of xy. So Vx is equal to f dash of xy, and I will multiply this y to this bracket x square y minus y cube. And I'm doing this because I have to take one more derivative plus 2x f of xy. So I will differentiate this once again, differentiating partially with respect to x. So we will have Vxx is equal to partial derivative with respect to x of f dash of xy in bracket x square y minus x cube plus partial derivative with respect to x of 2x f of xy. So Vxx is equal to, I'll keep this x square y minus x cube as it is, derivative of f dash of xy, this will become f double dash of xy into y plus f dash of xy as it is in bracket, derivative with respect to x will be 2xy minus 3x square. This is our first bracket plus in the second bracket, let's take 2 outside, f of xy, derivative of x with respect to x is 1 plus x as it is, this will be f dash of xy by chain rule, derivative of xy is y. So I will simplify this, Vxx is equal to, what I can do is,
Excuse me, sir.
I can just a minute, let me just simplify and then we'll talk. So I'll take x common from this, so x square actually, so x square y minus x f double dash of xy so in this what we will have
Excuse me, sir. So you have taken a wrong term in the
which
last
one,
line. Sir, x square y minus y cube, not x cube. Sir, in the last line.
this one,
Sir, second page. I mean first page, where you have written differentiation partially with respect to x.
yes, after that
Sir,
x square y minus y cube, okay, yes, thank you. So what change it will make, x square y का जहाँ पे derivative है, so this won't be there, right?
yes, sir.
Yes, this won't be there. Okay. So f double dash of xy. Um, oh, this will also change, right? This will be y cube. Okay, let me just write it down again. So this term will be as it is x square y minus y cube. So if we simplify this, so I can take y common. So I'll have y square outside in bracket x square minus y square f double dash of xy. Then let's correct the coefficients of f dash of xy. There is 2xy here and 2xy here. So totally we will have 4xy plus 4xy f dash of xy plus 2 times f of xy. This is equation number 1. So it is your task now. Find out vyy. You have 2 minutes. Do it first.
Sir,
Yes, Pratik.
x square into x square minus y square into f double dash xy
Just a minute. X square into x
into x
square.
square minus y square
Hmm.
into f double dash xy
Hmm.
minus 4xy into f dash xy
Hmm.
minus 2 f of xy.
You have done it. Solved it.
Yes, sir.
Okay. So adding 1 and 2. I'll write it down. Similarly, adding 1 and 2, vxx plus vyy. So minus 4xy f dash xy plus 4xy will get cancelled out. Minus 2 and plus 2 fxy will get cancelled out. So what we finally have is y square x square minus y square f double dash of xy plus x square minus y square f double dash of xy. And so I can take this common and we have x square plus y square x square minus y square f double dash of xy. So a minus b a plus b. Ultimately we get x raised to 4 minus y raised to 4 f double dash of xy. Which is the required equation. Okay. Example. Find the value of n. for which u is equal to capital A to the power minus gx sine of n t minus gx satisfies the partial differential equation. Double u by double t is equal to m into double 2u by double x square, where a comma g are constant. So what we have, u is equal to capital A e to the power minus gx sine of n t minus gx. So we are given that this u satisfies this equation. So if u satisfies this equation, then we need to find out the value of n. N is this. So we'll make it satisfy by taking the derivatives. So first of all, differentiating with respect to x. So we'll have partial derivative of u with respect to x is equal to a being constant will come outside. In bracket, I will have to apply the product rule over here. And derivative of e to the power minus gx with respect to x, that will be minus g e to the power minus gx sine of nt minus gx plus e to the power minus gx as it is, derivative of sine will become cos nt minus gx by chain rule, product derivative of nt minus gx with respect to x will be minus g. So if you simplify this, minus g being constant will come outside, minus a into g in bracket. Even e to the power minus gx will be common. In bracket, what we get is sine of nt minus gx plus cos of nt minus gx. This is ux. So differentiating this once again with respect to x, differentiating partially with respect to x. So uxx is equal to minus ag being constant, and then I will have to apply product rule on this. Again minus g e to the power minus gx as it is. And in bracket this as it is, sine of nt minus gx plus cos of nt minus gx plus e to the power minus gx as it is, and derivative of this sine will become cos. By chain rule, minus g will be there, minus g cos of nt minus gx. And in the second one, this will become minus sine plus g sine nt minus gx. So uxx, if you simplify this, Again, there is this g in both the terms. So I can take minus g common, e to the power minus gx outside. So we will have a into g square e to the power minus gx in bracket. When I take minus g, I will get 2 cos of nt minus gx plus sin nt minus gx, and after taking this minus g common, this will become minus. So sin nt minus gx will get cancelled out. So finally what we have is 2 cos nt minus gx. Please check the calculations. I may be wrong somewhere. So uxx, what we have got, 2a g square e to the power minus gx cos of nt minus gx. Sarthak, am I right?
Yes, sir.
Pratik,
Yes, sir.
no calculation mistake?
No, sir.
Fine. Now I have made a square to this, so I will change the differentiation now. Now I will differentiate with respect to t. So differentiating with respect to t. Differentiating with respect to t. So u with respect to t is equal to a into e to the power minus gx as it is. Derivative of sine will become cos nt minus gx. By chain rule, derivative of nt minus gx with respect to t will become n. This is your 2. And this is 1. Put 1 comma 2 in w by w t is equal to m into w2u by w x square. So we will have a e to the power minus gx cos of nt minus gx into n is equal to m in bracket 2a g square e to the power minus gx cos of nt minus gx. So e to the power minus gx will get cancelled out with e to the power minus gx. Cos nt minus gx will get cancelled out with cos nt minus gx. A on the both sides will get cancelled out. So what we get? N is equal to 2m g square. So this is the final answer. Then example. Find the value of w2z by wx square minus a square w2z by y square if z is equal to tan of y plus ax plus y minus ax raised to 3 by 2. Please do it. Yes, anyone?
Sir, 0.
Yes, let's wait for a while. The others will check it. Anyone else who have got a different answer?
So 0.
Okay.
Set 0.
So 1.
Yes, sir. Same zero answer.
0, 0.
So the final answer is 0. That's correct. Okay, next. If u is equal to log of x square plus y square, verify uxy is equal to uyx. So uxy is equal to u with respect to x, u with respect to y. So u with respect to y will be 1 upon x square plus y square by chain rule 2y. And then derivative with respect to x of this, 2y being constant, it will come outside. Derivative of 1 upon x square plus y square will be minus 1 upon x square plus y square whole square. By chain rule, you will have 2x over there. So the final answer is minus 4xy upon x square plus y square whole square. This is uxy. Uyx will be equal to partial derivative with respect to y of partial derivative of u with respect to x. So this is equal to, in bracket, derivative of u with respect to x. And that will be 2x upon x square plus y square. 2x being constant will come outside. Derivative of 1 upon x square plus y square is minus 1 upon x square plus y square whole square. By chain rule, we'll have 2y over there. So uyx is equal to minus 4xy upon x square plus y square whole square. So we can see that uxy is equal to uyx. And so uxy is equal to uyx. Fine. That's all for the basics of partial derivatives. I mean, complete almost. In the next lecture, we'll see examples on composite functions. So what do we mean by composite functions is, I'll just write down one example. Say u is equal to x square plus y square, where x is equal to r cos theta, y is equal to r sin theta. So what ultimately what it is there? So u is the function of x comma y, or to make this complication, what I will do is x cube plus y square. So u is the function of x and y. X and y are the functions of r and theta. Okay. So ultimately your u is the function of r and theta. So this is the kind of composite function. In the one variable terms, what you have seen is in your previous classes, it was given like f composed with g of x. This was called the composite function, where f of x is equal to x square and g of x is equal to sine x. So when I compose f with g of x, how you were simplifying this? F of g of x. What is g of x? G of x is sin x. So f of sin x will be equal to sin of x square. So this kind of composite functions you have seen. But now what we are going to look at, the composite functions of more than one variable. So u is the function of x and y are the functions of r and theta. It means that I can differentiate u with respect to r as well as I can differentiate u with respect to theta. Okay, so this we'll see in the next lecture. Fine. If you have any difficulties, you can ask, or else we'll stop. No problem. Fine.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Satej,
Yes, sir.
is there any lecture which goes off sometimes? I mean, it is not conducted or this kind of thing is there?
So mostly like in recent days, AMC lectures are not happening.
AMC. Who is teaching AMC?
Um,
Do you
just
know
a
the
minute.
name?
Yes, sir. Just Adinath, sir. Yeah.
Okay. So from how many days it is there? I mean, and does he have any extra lecture now after this?
Uh, like today, no. He had actually planned a extra lecture yesterday from
Okay.
8:30, but due to some reason it was cancelled.
Okay. And he has a scheduled lecture today or tomorrow?
For now, no.
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 So AMC lecture is directly now on.
On Saturday, 9:30 to 10:30.
Okay. Fine.
Yes.
Thank you. Yeah.